Happy Thursday. I thought from the questions I had yesterday, it would be beneficial to see some exercises worked out. So I wanted to show you a couple examples. Your homework has been posted. So the first example that I have has an E in it, and some of the homework problems that you have also has E's in it. And so on this particular problem, we have x squared e to the minus 4x cubed dx, and this is a substitution. So this may not seem like a substitution initially, but recall that when we did chain rule, we had you write e in this way, so you can clearly see that there's an inner and an outer. So the inner here is minus 4x cubed. So there's inside stuff. So if my u is following by the steps that I outlined in class, my u would be minus 4x cubed. And my du then would be minus 12x squared dx. The next step, as I'm just moving through the steps, it's a machine. Once I've made my decisions of what should be what, I just go through. So my next step is to actually identify or solve for dx. Dx is minus 1 over 12 x squared du. And if you recall, I was very careful to write it in this way so that the du is separated off. And that you'll see why in a second. It makes the algebra easier. Anything you can do to make your life easier, you should do to not try to make your life harder than it really is. So let me see if I can scoot this make it magnified a little bit. So let's see. And so this is what we have so far. Now I'm ready to substitute. This is not what we call a definite integral. You don't have limits of integration to change. So we skip that step because there's no limits of integration. Everything on your homework and everything on your quiz has limits of integration. So if there's limits of integration, you would take the step by putting the lower limit in for x and the upper limit in for x and then change the values in the limits of integration. We don't have that step. So what we do is we just go ahead and do the substitution, which is the next step. So this is a little bit different than what we did in class because we don't have a constant here. We actually have an x still. However, what you'll notice is that the x's will cancel here. The x squareds cancel. And I'm left with e to the u times minus 1/12 du. And it's not really nicely written, which is nice. I can just erase it here. And now I can factor out that minus 1/12. Andy, we need to factor out the minus 1/12. And we get e to the u du. Now I can find the antiderivative of e to the u easily. That's equal to minus 1/12 e to the u. And now this is not a definite integral. And if you remember the first day, I had a good laugh about my German friend who took a point off whenever a student forgot to put the constant of integration here. Because if I take the derivative back, again, the derivative of a constant is 0, and I'm back to where I started. So I need to add that constant of integration if I don't have limits of integration to worry about. And in fact, because this is a indefinite integral, I will have to resubstitute back because I'm not plugging or evaluating anything. So I get minus 4x cubed plus c here. Now, what's amazing about this is you can actually check your work by taking the derivative of what you just got. If we call this y, then I can actually calculate y prime. And this is actually a chain rule with an inner. Just to let you know, I'm checking my work. My inner would be minus 4x cubed. My derivative of my inner would be minus 12x squared. My outer would be found by covering up my inner with my thumb and replacing my thumb with an x. My derivative of the outer is minus 1/12 e to the x. because the derivative of e to the x is e to the x. So now I'm ready to assemble that derivative. The derivative of the outer with the inner plugged in for x times the derivative of the inner. And you don't want to forget those parentheses. So now I am able to cancel this, and there's no more negatives, and I get x squared e to the minus 4x cubed. Notice that the plus c dropped out when I took the derivative, because the plus c, the derivative of a constant, is 0. Now what you can tell now is, if I go back to the beginning of my problem, when I took the derivative of my answer, I got right back to where I started. So it's very similar to when you were in algebra class and they had you take your answer and plug it back into the equation to make sure it works. So there's a check. You will be asked to check your work by taking the derivative of what you got to get back to where you started, and check and see if that's correct. So that's one example of a substitution. I'm going to do a second example of a substitution. So let's see. So while the problems may seem more complicated, they actually still follow the rules the way we've had them done before. So let's try this one. Let's try the integral of x squared divided by 7 minus x cubed dx. So in this problem, the u is the entire denominator. We had a similar problem I did for the rock curve. And so, but this one's easier actually. The rock curves are just difficult because they're real problems, and real problems are never nice. So I get this 7 minus x cubed, the du, so I'm going through in the machine, it's minus 3x squared dx. The dx I solve for, and I get minus 1 over 3x squared du. I am absolutely not thinking right now, I'm just doing. I still stand by that. There's no thinking involved. I resubstitute everything in. I cancel. It's amazing. You've seen me make mistakes all semester long, but I don't make mistakes here. I think when I have to keep the books a little bit more and it's more involved, I'm much more careful because I know myself. I will make the mistakes. So this is where I'm at now. The Andy method, pull out the minus 1/3 into the front, and I get 1 over u du. The antiderivative of 1 over u is natural log x, or I guess natural log u in this case. You have no idea how nice it is to actually erase. Natural log u plus c, and then we resubstitute back. To check your work, all of these substitution problems are going to be chain rule, because as I told you in the beginning when I introduced this topic, this is really backward chain rule. So here, to check my work, my inner would be 7 minus x cubed. My outer would be minus 1/3 natural log x, I guess plus c if you want to add that. We can forget the plus c. The plus c is going to disappear when we take the derivative, so don't worry about it. We won't tell my German friend. My derivative of the inner is minus 3x squared. The derivative of the outer is equal to minus 1/3 times 1 over x. And now we can assemble the derivative. Y prime is the derivative of the outer with the inner plugged in for x times the derivative of the inner. So that's what I get. And now you can see this minus and these two things cancel. And don't forget the parentheses. So then we get x squared over 7 minus x cubed. And you can't see the top of my paper anymore. So I'm going to bring the camera up there, and you see I get exactly the same thing. X squared divided by 7 minus x cubed. So I'm back to where I started. So your antiderivative, you can check by just taking the derivative of what you got. You should get back to where you started. So these are checks that you can do along the way. One last problem, because I gave you lots of problems with different things in it. Sines and cosines, all the good stuff you love. And let's put some limits of integration on here. Let's put pi over 2 to pi, so that you can have one that's you can practice, where you can check your work that still have the limits of integration on it. So on this problem, it's not clear what to set your u, but that's because we don't write it this way. This is really cosine x quantity cubed. That's what that is. We just shorthand put the little 3 over here. Our shorthand is actually pretty confusing. And now my u is very clear. My inside stuff is cosine. And I'm not going to talk anymore, because this is actually a machine now. Du is minus sine x dx. Dx is du times 1 over minus sine x. I solve. And here I have to change my limits of integration. So my u was equal to cosine. I'm going to put my lower limit, which was, let it focus. My lower limit was pi over 2, so I'm going to plug in pi over 2. That's 90 degrees. Cosine at 90 degrees is the x value at 90 degrees, which is 0. So this is my new lower limit. And my new upper limit is equal to cosine at pi. Cosine at pi is minus 1. And I know that some of you don't have the unit circle, but you're allowed to use your calculator. Make sure it's in radians, and then use your calculator and just plug these things in into your calculator, and you will get 0 and minus 1. You have to have your calculator in radians. And so what we really have is we have the integral now from the lower limit is 0. Keep them straight. Keep them straight. I know this minus 1 is a lower value than 0, but just go through the machine. And we get the substitution is u cubed sine x. Instead of dx, we have minus 1 over sine x du. And nothing works like this in real life, but this is a cooked problem from a textbook, actually from the internet. So I can cancel those. Nothing is ever canceled for me in real life. So I get minus 0 to 1, minus 1 of u cubed du. And all I did is I pulled this minus sign out in front. And now this was a power rule. And before you ask me where this comes from, you're not here in front of me to ask me. I'm just imagining that you'll ask me. This was Monday's lecture, which is posted on Canvas. Minus u to the 4th over 4. Evaluated from 0 to minus 1. So I'm going to star this expression because I can show you how to check your work in a second. So now I'm going to evaluate f of b minus f of a. That comes next. In this case, b is minus 1 and a is 0. And now I'm able to evaluate. Watch out for your minus sign. Pull that puppy out in front so you don't make any extra mistakes. F of b means put minus 1 in for u, and then subtract f of a, which is 0, 0 in for u, and I get minus 1/4, which is really minus 1/4. Done. So why would this answer be negative? It's not a ROC curve. From pi over 2 to pi, sine is positive because it's above the y-axis, and cosine is negative. So the curve itself is negative, so your area will be negative, and that's why we get what we do. So how do we check our work? Quick check. When I took the antiderivative, I got minus u to the 4th over 4. Let's ignore that plus c. We need less trouble. That's really minus, in this case, u was cosine x to the 4th over 4. So now if I do chain rule, my inner is cosine x, outer is sine x. I'm sorry, the outer is x to the 4th. The derivative of the inner is minus sine x. The derivative of the outer is 4x cubed. And quickly, I can check. If I take the derivative, I get the derivative of the outer, which is 4, and I want the inner plugged in, cosine x cubed, times the derivative of the inner, minus sine x. And I think I've lost a minus sign here. The outer is supposed to be a minus x to the 4th. And so the derivative of the outer is a minus. So I have a minus sign here. And the two here, if you can't see, this was a minus cosine x to the 4th here. So the outer is minus x to the 4th, and the derivative of the outer is minus 4x cubed. So prone to sign errors. And when we simplify, we get, I forgot the 4 here. The 4's cancel, the minus signs cancel, and I'm left with cosine x to the cube times sine x. Well, that's what I started out with. If you go back up to the top, cosine cubed x times sine x. So you can check your work even on definite integrals, but you have to resubstitute back to do that check. And I would recommend doing that check if you have time. And so that's it for substitution. I'm going to sign off and do a couple integration by parts.